Today we're going looking at force-directed network graphs in D3, and while you can do some of the other graphs that we've done, other graphing packages do them, and it's a question of taste. There is no package that does a force-directed network graph as well as D3. The example we're going to look at is character interactions in The Godfather, which we have here. So you can identify there's Salazzo the Turk. This is Michael Corleone, Fredo, Don Corleone. All your favorites are here. And the nodes are draggable, so you can move them around a little, and then they bounce back into place, which sometimes helps the network network sort better. The source for the data is here. It's the Harvard Dataverse, and I think there's up to 700 movies in this in GXF form. So I chose The Godfather as the one that's most likely to be familiar to the greatest amount of people. And the format that we're going to use, it's a JSON file, and the JSON file is 2 keys. Each is a key to an array. There's a node array and a links array. So the nodes are objects with 2 key value pairs. There's an ID and a label. As you can see here, Michael Barzini, Don Corleone, all the rest. And then the second links list or array is it's an array of sources and targets, source, target, all the way around, and that's how these particular lines are drawn. So Salazzo links to Bruno, Buonasera links to Don Corleone. Buonasera, you may remember, is the Undertaker at the start of the movie, and the links are drawn by dialogue. So these is someone speaking to someone else. That's how they're drawn. But anyway, it's just a data set. It's the handiest one to use, and we're going to look at how to display the data set, how to tweak the display of the data set, how to color the nodes, and all that interesting stuff. So we're as well to start with that. So we'll clear. This is the JavaScript we had from the tree map last time, and we'll reduce, reuse, and recycle as much as we can. So we're going to put the headline on this will be character interaction in The Godfather. We'll put The Godfather in italics because we can. You might see in the bottom right hand corner I have a key tracker, which I suppose I should have had from the start, but it's never too late to do the right thing. Ask anybody. You see I'm a regular saver. It's something I recommend to everybody. And we can get rid of all these different objects that we had to create for the tree map. Get rid of the visualization, get rid of the labels. Even the comma formatter has to go. We're going to keep the tooltip because we can use that later. Now, our draw function is going to change a little, and the reason it's going to change is, whereas before we only had to load 1 data file, here we have to load 2. And if you're loading 2 or more data files, you need to use a promise all constructor. So you type promise, call all, brackets, and then that takes an array of D3 JSON promises or D3 CSV promises, depending on the data that you're calling. And what that does is, whereas before it sent the file directly, it now sends an array. When we call then, the data that's sent to draw graph is an array, rather than the JSON object that it was previously. Meaning that when we get to draw graph, then we have to separate the data into its component parts. So color map, we're going to set color map equals data 1 because that's the second element in the array, and we're going to set data itself equal to data 0, and we log that to the console. go over to the Fox and see how it works out. And of course nothing happens because I forgot to launch the server. Okay, so open the terminal in VS Code. That's Control Shift backtick, then Python-m HTTP server. Back to the Fox. We'll open up the console, blow it up so you can see it, hopefully. And don't mind this, something has gone wrong. That's just from the rest of the code. This is what we're looking for, and we see the links array that shows source target, and the nodes array that shows IDs and labels. So that's fantastic. Back to VS Code, and we'll do a little coding. So we'll get rid of the log in the data to console, tidy the thing up, and here, just after plot, we're going to create 4 functions. First function is called update nodes. Second is update links. The third is called ticked, and the final and most important function is force simulation. It's not it's an object. It's a function. You know, JavaScript object functions, they're all kind of the same. Anyway, there's a D3 force simulation object that runs an algorithm that places the nodes in a network diagram in their idealized space. This is done by running the algorithm, running the simulation 300 times. And over each iteration, each node is repositioned until by iteration 300, they're in their ideal place, according to the forces directed on them. We're going to direct 3 forces on them. The first force has to do with the charge of each individual node. The second force has to do with how the nodes react to the center of the plot. And the third force has to do with the links between the nodes. And these each take 3 D3 force objects: D3 force many body, D3 force center, and D3 force link. Now, what exactly these things are, you can read in the documentation, and if you can understand it, give yourself a gold star in your copy, because you're very, very smart. I can't understand it, but my general understanding is that the charge has to do with pushing the nodes apart, center has to do with pulling them together, and link has to do with how the nodes are linked to each other. And there are different ways of pushing and pulling them, of fine-tuning them. But we're going to worry about that after we've got them working and not before, because this is very complex stuff, and the most important stuff is to get a viable working product, and that's what we're going to do. Okay, the update nodes function is essentially a scatter plot, right? Because what is a node? It's like a circle on a scatter plot. So we run through the scatter plot configuration that we're so very familiar with here, noting one difference, which is that we join circle here rather than data with circle, rather than just use empty or enter, excuse me, with no parameter. The circles have 3 attributes: cx for center x, cy for center y, and a radius. And as well as that, we're going to set 2 style parameters, one for the fill and one for the stroke. So each time the D3 force simulation runs, one of the things it does is it runs this update nodes. It runs this update nodes function, and each time, on each iteration, the nodes are moved slightly in, out, up, down, relative to where they were the last time, until the thing runs its course and the nodes have found their ideal finishing location. So we use the color map for the fill, for the stroke. We use my let's be honest, beloved D3 color darker method, which I just hopelessly devoted to it. I really am. It's pathetic, but they say you should never love what can never love you back, but well, here we are. Okay. The, the next function, right, is update links. Update links is simple. Because what is a link? It's a line. What is a line? It's a line between 2 points. So we have 2 points, x1, y1, x2, y2, and we plot those according to the source and target xy values. The xy values are created as part of force simulation. So as force simulation runs, each of the links is given an xy value. Each of the links is given two xy values, one for source, one for target, just as each of the nodes is given an xy value as they're positioned. As the force simulation object keeps running, keeps positioning the links and the nodes. Okay, so we source target x, source target y, target x, target y for x1, x2, y1, y2. And then the ticked function itself, what does the ticked function do? Well, what the ticked function does is it runs the update links and update nodes functions. That's all. Now, we're going to bring into the fold here the tooltip behavior, because if we don't bring it into the into ticked, then the tooltips won't work, and what would be the point of them if they don't work? So they won't have scope. So we have to bring them into the ticked, the scope of the ticked function. So we just paste them in as they were before, and we make one little change here, and that is where viz was an object before, we now have to go plot select dot viz, because we've added viz as a class, whereas before it had existed as an object in scope. But it'll work out fine. We killed the models thing from the old tooltip, that doesn't matter, and we have a much simpler call to HTML, which is just going to be d.label. We don't need a tooltip text function. It's just going to show d.label, which is the character label on the node, associated with the node. So there's no point in having something more complex than it needs to be. This stuff is plenty complex already, right? Why would we make a stick to beat ourselves with? Just format the document here, because I've made a lot of changes and just want to tidy it up a little. And then we're just going to add one line. Well, we can kill some of the old the tooltip table stuff that we had. We can take it out of the CSS. We're going to add one line of CSS, which is line, an SVG line, and we're going to give that a stroke width of 1 pixel and a color of grey, because we want the links to be subtle. We don't want them overpowering. Okay. Right, we might as well give this a spin and see how it looks. Open the terminal. Look for a previous call to python-m http server. There isn't one. Type it out. Launch the Fox. Hope for the best. Alright, something's gone wrong. On is not defined. Why wouldn't it be defined? Okay, because it's not chained. So there isn't a dot in front of on in our simulation. Just line it up, add the dot, save it, refresh. Okay, good news, bad news. Here are our nodes. They're not in the wrong place, and I can't see any links. Now, our error tells us that D3 color is null. That's disappointing. Might have a look at the color map. Actually, code there looks fine. We'll change style to attribute, sometimes, you know. It's not working. So what we'll do is we'll comment it out because I was talking earlier about a viable working model. And I still see in D3 color even though we've commented it out. Log the color map to the screen, or to the console I should say. Fox again. And now that I think about it, the nodes are colored, so there isn't a problem with the color map. The tooltip is working. I think I know what it is. So we'll just go back to the code and fix it. So we can delete the color map. The color map's working fine. We're wrong to doubt it. Now, in creating the simplest viable model, I forgot to leave out a vital component for center, which is to tell the machinery where center is, and it's half a plot width, half a plot height. So we're going to save that, clear up some extraneous space here. And then we're going to launch the terminal, launch the Python server, and launch the Fox, get a look at it. And this is much better now. So here we see our nodes, we see our links, the tooltips are working, the color map is making sense, the Corleones are all one color, the Sicilian people are all one color, the Sicilian chapter, say, of the movie, Salazzo's gang are all one color. Okay, I just saw some extraneous space there, and I was wondering if there is extra tooltips being created, but there aren't. Just that the tooltip box is a little too long, so we'll go into the CSS and change that. If only everything were such an easy fix. I will change the height of the tooltip as well. I'll give it a border. Everything looks good here. Now the links are a little short, so we're going to give them a distance of 75. Distance, you know, it's one of these things, there isn't a set value you can give it. It's something that you do by trial and error. And I noticed as well that this isn't very clear. One of the reasons it isn't very clear is because the links are being drawn over the nodes, and the reason for that is in our ticked function we have the order wrong. We ask it to draw the links after the nodes. We should ask it to draw the nodes after the links. Reload, and isn't this much better? It's much better. It makes a little more sense. Now we can add a parameter onto force many body as well, which we're going to add. It's a parameter called strength, and again, like distance, there isn't a there isn't a set thing that you can say, well, I have 12 nodes, therefore I'm setting the strength at 70. It doesn't work like that. Yeah. This is much better. Much better. You see how Michael is really the center of the story. So much goes through Michael. That's worked out really great now. Very happy with that. Very happy. Just need a little bit extra width in the tooltip. The Dawn was getting crushed. The Dawn doesn't like getting crushed. So we just have two more things to do um, with the force graph. The first thing is that even though the simulation runs what it considers to be the best positioning, it's no harm to be able to override that, and for that dragging is invented. So we write a drag object, which is d3 drag, and we instruct it that on a drag event, it's to call the handle drag function. The handle drag function takes one parameter, which is e, short for event, and it is told to um, e subject x equals ex, e subject y equals ey, and then you call update link, update nodes. Then, once that's written, you go to the ticked function, and up here we write d3 select all circles. Excuse me, d3 select all circle singular. And call drag. So we launch our terminal, just Control Shift backtick after we save it, obviously. Then Control tick backtick will open the terminal in VS Code on a Mac. Python-m HTTP server, launch the Fox. So what we can do here is we can take a node and we can drag it and drop it and place it where we like. So what I'm doing here is I'm taking the Sicilian characters and putting them in one side of the graph, and then we can take Salazzo and his gang, put them over here, move the Corleones over to the left, and all that. You see how it works. So that's the network. The network force graph is now done, and there's just one last thing that I want to go back to, which I think is amazing. You remember back in lesson 9 we looked at labels that were crowded on a line graph. Force simulation can fix it, just like this. So this is the multi-line graph that we created back in lesson 9. And we noted at the time that the labels are scrunched on top of each other, and we promised a fix. This is the fix. So we're going to go into the code on GitHub, and we're going to copy all this into a new folder here that we've called line labeling, and we're going to use a force simulation object to force those labels apart from each other. This is the D3 is the only graphics package I know that can do this, that can adjust labels like that without you having to manually adjust them one by one. I think it's amazing. It's amazing. Now, far from intuitive, but amazing. So we're going to get rid of the old legends, and we're going to make a note of what we got to do, as we've been doing before, where we make a list of things we have to create using comments. We need to create a legend object that's going to contain the details of the legend. The details we're going to feed to the force simulation object to tidy up the legends. We're going to create the force object itself, and then we're going to create the legends and put them on our plot. Okay, so the legend object we're going to call legend details. Now, if you take a look back at the original code, the code is, we used the D3 group to group the here it is. No, that's not it. That's the actual plotting. I go to the top. Yeah, we used a D3 group to group the to create a map that groups the data by year. So to iterate over a map, you call for each on the on the map, and then you carefully note that the order is value key, whereas in Python it's key value, and key value might be a bit more intuitive, but this is always planet D3, and when in Rome you do as the Romans, so this is just how it is, right? Okay, so on each iteration we identify the year as the key. Y position we identify as, we're calling Y scale on the maximum value uh, of the cumulative participation by year value in our value array, and we're going to set a color, and we're going to get the color by using key as which is the year in color scale, and then we're going to create an object and push those three details plus an x value on a we're going to push those to legend details. The reason we don't create an x value specially is because there's no need to iterate over the x values, because the x values are always the same. They're always the furthermost point along the x-axis. And then the y value is y position, color is color. Right, so that all makes sense. We're just going to plot that to the console now, just to make sure it's worked out. It's worked out properly, because we're cautious people. Go home, that hasn't come up. Kill the fox, relaunch the fox. Oh, I just need to change into the folder that I created here, which is line labeling. Launch the server. Launch the fox. Open the console. And D is not defined because I left the head off the arrow. You know, that really is the most common typo that I make in JavaScript, is leaving the head off the arrow. I don't know why I do it. Just stupid, I suppose. Anyway, our legend details array is coming out just as we want it, with the values all there, just as we want it. So the next thing to do is to create our force simulation object, and I'll spare you the iterations that I had to do to create this force simulation object. I had to try a few different values on the thing, as you may have to do yourselves with different multi-level thing, but this worked for me. So we call D3 force simulation with legend details as our as a parameter to force simulation, and we call two force methods. One is force x, which takes a D3 force x object. The D3 force x object takes d maps to dx as a parameter, and we set a strength after a certain amount of trial and error to 0.5 here. Then the second force is for collide, and that takes a D3 force collide parameter, and that takes a parameter of 10, and then we call stop at the end, otherwise it'll iterate forever. Now, instead of having calling on with ticked as a parameter, we're going to call tick on our simulation object 250 times using a for loop, because it works out easier this way. Okay, then when our simulation is run, then we plot the legend as we plotted the legends before, except where we were looking at live data, at data from the plot for the x and y values, we're now using the X and Y values that were created by running our force simulation object 250 times. These are the new X and Y values that are different from what they would be if we just took them from the plot. Well, the X is the same, actually. The X is the same, but the Y will have changed because we're only moving it in that, we're only moving them in that vertical plane. And because it's a vertical plane, it's a force X. It's the opposite of what you expect. It's force X is one of the forces that we call. If we had to move it in the horizontal plane, we'd call force Y. I don't know why. Again, I'm sure Mike Bostic knows. But again, we're in Rome and we're doing as the Romans. This is what works. So we save it. We're going to format the code, just tidy it up a little. Save it again and over to the Fox. Okay, our labels haven't appeared. There's a problem on line 126. Okay, and I force L instead of collide. That's an easy fix. Reload it. Still no graphs. Might be cached. Close the Fox, open the Fox. Still no labels. Look at the console. D is not defined. And again, I forget to put the head in the arrow like a muppet. And here we are. Here are our labels correctly separated. And now we just need to put a little more height on the graph. So we'll increase the top margin to 30. This is the reason we have margins, because it makes it very, very simple to add a bit of height when we need it. But now you'll see that the legends are laid out correctly, near enough to they're correctly colored, and they're near enough to their endpoints to associate with their endpoints, so that your brain doesn't have to think, which is the last thing you ever want a user to do. Again, this is one of the things that makes D3 worthwhile. As often as D3 will break your heart, and D3 will cut your heart out and eat it and consume it like a monster from the very pit of hell, and yet you keep coming back because D3 is the only thing that can deliver results like this. It is the best online graphics package. Okay, I hope you enjoyed that. Please like and subscribe to the channel. Until next week, live long and prosper.